Hello everybody and welcome back. Root Beer here and hope you're all doing well. We're going to be looking at question number 16 in this video on our 2009 Fermat paper. 6 dice are stacked on the floor as shown. On each die, the 1 is opposite the 6, the 2 is opposite the 5, the 3 is opposite the 4. A regular die, okay. What is the maximum possible sum of the numbers on the 21 visible faces? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There'll be similarly 6 back here, and then there's going to be 3 on the side here. Okay, so that's 6 and 6 and 6 is 18, plus another 3. Okay, it is 21. Okay. So we want the biggest possible sum. I guess we get to arrange these dice here. All right. So how might we approach this question? Well, if we brought some dice with us, this, would be something that we could experiment around with. But if I want to maximize the visible faces, I think my plan of attack is just going to be going from dice to dice and saying, okay, which faces are visible? And then asking, well, how can I sort of place a die to maximize the faces that I can see? So the first thing that catches my eye is that lone die up at the top here. Because the only one of its faces I can't see is the one that it's resting on. There we go. So if we sort of imagine in here, I can't see that. So if I want to maximize the visible sum, maximize make the faces that I can see as large as possible, I want to minimize the hidden faces. So what should this face be? It should be a 1. So I should be hiding a 1 here. Okay? And I think if I just go through, there's only 6 die, so I don't think searching for some sort of grand pattern is going to be what the doctor ordered here. I think if I just go dice to dice and say, okay, what can I see? What can I make? What can I hide to make the rest of the numbers as big as possible? So what can I hide? What's the smallest stuff I can hide? I think going down the staircase is good. So here we're losing a 1. I think I'm just going to keep track of what I'm hiding. So this next, I don't know, we could color it purple. So the purple die has 2 faces that I can't see, and 4 that I can see. Okay. Now the 2 faces, I probably want to turn it so there's a 1 being hidden. Okay. So a 1. But what about the other face? Well, if the 1 is hidden, I know for a fact the 6 has to be visible. But other than that, I can rotate the die as much as I want. So how about we rotate it so that 2 is hidden as well? So now we're hiding sort of 4. Okay. I'll erase the 6 so I don't confuse myself later. And the same sort of thing, actually we'll keep purple, the same sort of thing is going to happen down here for this die. 2 of its faces are hidden as well. So we could make it the 2 and the 1 again. Alright, now we've got a couple more die. These 2 orange die will behave the same way. So actually, I could, with the way I'm handling the question right now, I could sort of generalize it, I think. There's only going to be certain ways that the die faces are going to be occluded. So these 2 orange die, they both don't have the right side, their top, and their bottom visible. Those are the ones that are hidden. Now, this is getting actually kind of hard, so I'm just going to draw a bigger die. I mean, I have the whole page here. I can use as many pages as I want. Why am I just hiding it up in the corner there? Now, so I don't have the top face, I don't have the side face, I don't have the bottom face. Now, they tell us in the question that sort of the 1 is opposite the 6, the 3 is opposite the 4, the 2 is opposite the 5. So opposite faces, like the blue face back here, and the blue face up front, opposite faces, just like on a regular die, have to add up to 7. So these two add up to 7. There's nothing I can do. There's no rearranging of the cube or of the die that's going to save me on that. However, this face, the face along sort of the spine, I can choose. Okay, and that would make a difference. So if we make that a 6, then we get a 1 here. And then I don't care. We'll make this a 2 and a 5. And so the 3 and the 4 are still visible. Okay, but here we're hiding the 1, the 2, 1, and the 5. So we'll write that down. Hide the 1, the 2, and the 5. So we'll hide the... We've hidden a 1, we've hidden a 1 and a 2. We've hidden another 1 and a 2, the purple die. And now we're hiding a 1, 2, and a 5, and another 1, 2, and a 5. And this leaves only 1 die left. I suppose we could make him green. But if we, and I'll make a larger copy of him as well. But if we look at this die, well, we just have pairs of opposite sides. Top and the bottom are invisible, either by the floor or the die above it, and the 2 sides are invisible, so it's really just the front and the back that we can see. But what did we just remark? Opposite faces always add up to the same amount. So, we could make this have the 1, 2, 5, and 6 hidden, for all we care. 1, 2, 5, and 6 hidden. I'm keeping track of what's hidden, just because I think it's going to be easier to add up. You could absolutely do this question by saying, okay, up on the top face here, that we've got a 2, 3, 4, 5, and a 6 visible. If you want to do it that way, that's fine too. But here I've got 1, 3, so 1, 3, 3, 8, 8, and then 2 7s, 14, 14. And if we add that all up, 2 14s is 28. 2 8s is 16, so that's going to be 44. Plus the 2 3s is 50. So we'll have 51 that's hidden. Now, on any die, you get a 1, 2, 3, 4, 5, and 6, and that's a total of 21. So the die regularly show 21. How many do I have? I've got 6 of them. And that's a total of 126, and I'm just hiding 51 of the 51 in terms of total value. So that's going to be 75. So is 75 one of the possible answers? It's not. What did I do wrong? Must have done something wrong. I'm just trying to figure out what. Did I add these wrong? That makes 30, and that's 44, and that's 50, and that's 51. And I do usually get a total of 21. 21 times 6 is 126. So what mistake have I made? Hiding a single 1, hiding the 3, 5, 2, and 1 is 8. This is 14. 8, 3, and 14 is 25. 25 times 2 is 50. And add on the 1 there. And the die usually show a 21. 21 times 6. Get out my calculator. Yeah, I'm getting 75 as the largest possible sum I could show. And yet I don't see 75 anywhere on here. That's annoying. That is absolutely annoying. Okay, new strategy, I guess. For some reason I've goofed on this question. So let's try it a different way. Let's count up what I'm showing. Have I just made an assumption that 2 of the die act the same way when they don't? these two purple die both just don't have their bottom face and the left side shown. And if I make those as small as possible, the 1 and the 2, then I'll be left with a 3, 4, 5, and a 6. And a 3, 4, 5, and a 6. So those are the visible faces. And now this top face, I guess I'll make him orange. Although I guess another pair of die were orange, weren't they? He will hide the 1, so we'll have 2, 3, 4, 5, and 6 visible up here. Okay. Now the green die have their front, their back, which have to add up to 7, and this side visible. So that's 6 plus 7. That's going to be 13. 6 plus 7, 13 is visible here. I guess here we have 18 visible, and 20 visible on this top one here. And then this blue die in the middle here. And the only thing visible on it are the front and back faces, which must add up to 7. So now what do I get? I get 20, 18, 18, 13, 13, and a 7. Those two are 20, so that gives me 40. And then the 10s give me another 30. So we'll get 70. So already I'm skyrocketing past the other amount that I had. Because then I have 2 8s is a 16, and then a 3 is a 19, so I'm going to get 89. Which is one of the answers. Okay, fine. So I get C89. But what did I do wrong? That's what I want to know. What in the world did I do wrong? Ah, there it is. I don't have 2 greens. Oh man, I wish I'd known that. So that knocks off a 14. And so then it's 41 minus 4, so it's a 37. So 126 minus 37, and that absolutely is 89. Ah, rats. I should have been more careful, especially because this is question 16. Look at how much time I wasted. Or would have wasted if I'd actually done the, or if I'd actually been right in the contest. But, oh dear, my sincerest apologies. I hate when I screw up something small like that. Alright, it's fine if I just don't get a question, but I should know better. So, alright, well, let's see if we can't wipe the slate clean with question 17, and we'll deal with that in the next video.